Okay, let's start again. We keep going with our overview of the initializations. So we were here. We're saying that these two syntaxes that looks very similar. We initialize without arguments. They have two different behavior depending on the type that we are initializing. There are other ways of initializing. It's called value initialization in general, where we use the parentheses or the curly braces. But the curly braces do not have the same meaning if the case of T is an aggregate, or if a class that I'm trying to if the class I'm trying to initialize as an initializer list constructor. We will see what this means. There's also a special case which is the zero initialization, which most the thing which is interesting here is that if you write the int z and the empty curly braces, this will initialize z to 0. Okay, so if you don't write anything here, if you don't put the braces, z will have an indeterminate value, which is the one, basically the one that is on the stack. Or, but if you put this, the empty curly braces, you will have the 0 in initialization. If you put the value inside there, you will initialize the integer to that value. The zero initialization happens for static variable and also the class data members without constructors. So if my class is a data member, which is an integer, it will be initialized with the zero initialization. We'll see examples. And also if I have a char array, if I have a char array of 10, and I initialize this to 0, you see only 4 characters are there. The other 6 will be initialized to 0. Now you are guaranteed that this happens. 0 in the C-style string will indicate at the end of the string. But let's move to pods, so POD and aggregate. POD stands for plain old data type. It's basically what the struct in C is. Right? So you take a struct in C, and it's basically that, just a collection of data items. In Pascal, I think they were called records. So a POD class is all the data members of this class has to be PODs. They cannot be references or virtual members of this class. There's no user-defined constructors, so it obeys the rule of obeys the 0 rule, so no constructors at all. And same access control for all data members. So they are all public or all private or all protected, and an array of PODs is also a POD. So this is actually this shouldn't be a POD because these private members and public members. We can check if you have the doubts. Like I have the doubt too. But these are the rules, so this shouldn't be a POD class. And aggregate, more interestingly, is basically something that all members have to be public. So it's just a plain old data type, so it has just a collection of data items. All data members are public. There's no constructor, no virtuals, no public basis, so you cannot inherit. And it can be also an array type. And from C++ 11, an aggregate can be initialized in a special way. Yep.
If the pod have to be all public or private, the members, and the aggregate is just public members.
Yes, all public.
Can I have a class with all private members?
Yes.
Can I do with that?
Oh, that's a POD. What can you do with that is up to you, but you can actually play a lot of tricks with that. It's not clean tricks, but you can do a lot of stuff with that.
So it's the same then as POD as struct?
Sorry?
Is it the same as struct, POD?
Yes, as a C struct, they say. Struct and class in C++ are exactly the same things, only that the struct is by default public, and the class is by default private. If I take a C struct, then the idea is that the POD is equivalent to that. And I'm actually curious about this, so we can go to the compiler explorer that we will see more after. And we can do class A Yeah, this compiles. So this is a no, but well, it compiles, but you need to see if it is a pod. If it is a pod. Well, let's put in here.
It should be.
Is pod static assert. Static. It's difficult to type in this way. It's POD A value. So this is the syntax of the static assert. Compilation failed. How do I see what the compiler did? Do you remember how to get the output? Okay. The static assertion failed. So if I put this one, if I put everything private, this compiles. Okay. So they must have, so the example I put there is not a POD. But what's interesting is really these guys here, aggregates. Aggregates are pretty useful, pretty cool. Aggregates can be initialized with aggregate initialization, or it's also called struct initialization. You can find both names. And it uses the curly braces to initialize the data member in order of declaration. So if I have a struct aggregator, which is an integer, a float, and a char, I can initialize my struct with 3, 2, and C. There will be, after this, we have an object X with those 3 fields set. What's interesting is that of course, this is also recursively true. So if a data member of that class is also an aggregate, I can initialize that thing using the same syntax. And this can be done at compile time, right? So I can tell the compiler initialize these values in my code directly. So suppose I have this very weird structure. So I have a struct. So a short array 3, which has contains 3 integer. A short array of 5, it contains a small array of 5 elements, of 5 integers. And then I have another struct which contains 2 arrays. One is the short array 3, and the other one is short array 5. And plus, I have also a data member, which is an integer. I can instantiate these 2 arrays, this object here, I call it 2, and I initialize the first array with 3, 2, 1, the second array with 5, 4, 3, 2, 1, and the integer with 324. What I can do, I can put the keyword constexpr in front of this variable. So I'm telling the compiler, I want to have this variable available at compile time. And then I can check at compile time, calling the static assert that we saw in the little example there, if 2.x is equal to 324. So if this is true, the compilation completes. Otherwise, it will give you an error. In this case, it is true. Without the constexpr, this is not the compile time variable. So it will be instantiated on the stack. In this case, it will not be instantiated on the stack. It will be internal representation from the compiler. So why do you need that? Well, there are several cases in which you might want to have something like this when you build abstractions. So per se, this example is a little bit silly, but there are cases in which this is very handy. Yeah.
So if you put the curly brackets without the equal sign,
if you don't put that one, it will work too. In this case, or I need to, in C++11, you need the double brackets in C++11, maybe. Yeah, so in C++11, it will work in a slightly different way. So if I force, let's see, what was the case? Can I copy this one? My computer is so overloaded at the moment that. Let me put it inside main. I like when it is in main. Okay. Now I'm compiling. Why? Oh, goodness. All right, yeah. Oh, yeah, it's okay, so this compiled. And now, if I do this, well, I need to, this will compile, but if I force std to C++11, this should, okay, might be just the compiler that does it. Because I think, in principle, you should put something like this here. Or maybe for integer, it doesn't. If you have arrays, you definitely need to do the double parentheses.
there are no structures.
Oh, yeah, okay. Yeah, because those are directly fields. If it was an array, if this was an array of 3, this will, in C++11, should not work. And you need to put something like this, right? Narrowing job. And this will initialize the first element of that array to 3, and the other one will be 0. So it is equivalent to 0, 0. And you need to put the double, the parentheses.
In latest C++, it's not the case?
In latest C++, there are examples in which you can, if it is just this, where is it? If it is like this, let's put it this way. So this should compile in C++11. I messed up with the values here. Yeah, so this compiles. If I put the C++11, if I put this one should not compile. It actually works. It's maybe the compiler is too new. I don't know. Shouldn't compile.
No, it should compile. It can produce warning.
Yeah. Yeah, I cannot reproduce the error that I had sometime. I have an example in the slides. Yes, but then if you have several arrays like this, you have to isolate. You have to isolate into this is an array, this is another array, this is another class. So you have to do it in this way. But the cool thing is that this can happen at compile time. So why do you want to use aggregates in real life? Well, std array is an aggregate. Std array is something that is a C++11 feature. You might say std array of unsigned int. I want to store 3 unsigned ints, and then you can bound it to. You can assign those values to these values here. This example was selected. We call it bounds because the idea is that you can have, for instance, your loop bounds. If you know the loop bounds at compile time, you can set these values here. You can have the loop bounds at compile time, which is very useful. And then you can check at compile time if the bounds is what you are expecting. And brace elision, this is where brace elision comes in. Sorry, I was a little bit confused. So if I want to initialize bounds in C++11, I should have done this because this has an array inside, even though apparently you could also do it with, because this one is a data member, so you have to put these double braces. Or you can do equal with this. And so it's just different way of writing the same thing. But now we have seen the initializer. We've seen the struct in initialization for aggregate. C++11 gives you another feature, which is the initializer list. So initializer list is a type. It's a std : initializer list of type t with my integer or whatever. And then you can use the brace, the curly braces to initialize your values. For instance, I have a class X, which contains a vector of char, and I have an initializer list constructor. So I have a constructor of X that takes an initializer list of chars, and I pass it as a regular function parameter, and then I can initialize V, my array, with these chars. So the vector has an initializer list constructor, which means that I will initialize my vector with those values. So if I initialize X with HELLO, then I will initialize my vector V with a vector of 5 elements. So the first is H, the second L, the second E, then L, L, and O. And I can also do it by using the assignment. So this will be, so the compiler will look at this and say, this is something, let's see if this class has an initializer list, and pass it to the initializer list constructor. If I can also have a function that takes something. So for instance, this is a template function that takes something, which I call chars, and I can copy. I can copy my chars. Actually, no, this is actually sorry. I can print these chars from these functions. Right? For each element in these chars, from beginning to end, print this as a DC out. We will see all this syntax shortly. And then when I can call f with chars, chars is an std initializer list. So at this point, I pass the initializer list, and I can access the initializer list as I will access any other container, and I can print the content. But if I call f directly with these guys, with just my sequence, this will not compile, because the compiler cannot take this brace thing and say, this is an STD in initializer list. Let me call f with this type where t is STD in initializer list. It will not do that for you. So you have to tell, I want to instantiate explicitly an initializer list char that with these guys over here, with the hello. So basically, this works because when the compiler sees these brace with the list of items and close brace, it'll search for a function that takes initializer list. It will not assume that this is an initializer list. And even though it might sound strange, it is actually pretty sane, because you might use the brace in initializer also for other things.
And in the constructor, where you say we merge some jars to B,
Yeah.
it was not curly braces, but normal parentheses.
Yeah.
Would it work?
Yes, because the type is clear now. It's STD in initializer list, so it'll go to the initializer list. Usually we use the curly braces in the initialization list, because then it's clear that it is a construction. So this is called initializer list constructor. STD vector has an initializer list constructor, so we just pass it and will be construct the vector. And also I can use this STD initializer for other things.
Can I still get something? The f function is a template function, so like when you call the function, you have like the as a template argument to the function.
Yeah.
I mean, I don't see it there.
Oh no, you don't have to pass the argument. Yeah, we will talk about this later in full detail.
I would like to add that the main purpose of the existing initializer list is to allow the brace initialization for the user classes as it is for CRS. So
Yeah.
before C++ 11, there was no way to initialize vector with the literals.
Yeah, exactly. So if you have your class and you store you have your class which represents a container of things, and you want to initialize your container with some values, straight there on the line. Before C++ 11, you will have to instantiate the vector, and then have a for loop that goes and do pushbacks or something like that to go and initialize those values. With the initializer list, you have a common uniform way of initializing containers for STD vector, but also for your classes if you desire so. So, for instance, now we have these two lines, STD vector of int 10, 4. Only one is with the parentheses, and the other one is with the curly braces. What happens in the first case? Okay, what is the difference between these two lines? Yeah?
The first one gets like a vector of size 10 with all the members, all the equal to 4, right?
Yeah. The second one?
The second one is a vector of 2 elements, 10 and 4.
Yeah. So the first one is a vector of 10 elements equal to 4. So 4, 4, 4, 4, 4, 4. And the other one is a vector of 2 elements. One is 10 and the other one is 4. Now, what's important to remember is that initializer list will take precedence. So if there is an initializer list constructor and you put the curly braces stuff, it will go to the initializer list. Another very important initialization mechanism is the copy initialization, where we have the type X equal and some expression. And when we have something like this, we call it, there is something called overload resolution that will look for the best way to transform the result of the expression into something of type X, which is something that might actually trick you at times. So let's consider the destruct B here, which has a data member A and a constructor that takes int X, and then we construct A with the value here. When I do B, when I instantiate an object B of type B equal to 40, this will take this value and look for a constructor that takes an integer or something that can be converted to an integer in this case, because we have a constructor that has an integer. And then we'll basically call this constructor here, and A will be 40. Right? So here what happens is actually very clearly specified. You take the value on the right side, and you look for a constructor that takes that value, or something that can be converted from that value. If you don't want this to happen, which is something that you might want to avoid, B is not an integer, so why should I assign an integer to B? So if I don't want that to happen, I can put the explicit keyword on my constructor. Say explicit B, and then this will become an compilation error, but I can do an explicit casting from an integer to my type B. So this line will actually work, and we'll call this constructor. So the copy initialization actually transforms values. Let's copy initialization for another time. Oops. So let's investigate a little bit more about this explicit keyword. The explicit keyword is pretty handy if you want to control what the user is allowed to do or not, or how much aware your user should be when it does something. You don't want the user to write any code that magically works, and the user might feel a little bit lost. So why does this thing work? So you want to control a little bit what the user is allowed to do with your classes. So if I have a struct B, which has two data member, A and B, this is also another feature of C++ 11. You can put the initial value of your class here. You have two constructors. One takes an integer, another one takes two integers. The one that takes one integer initializes only A, and B will be left to 10. And the other one will initialize both integers. And you have an operator int, which is a conversion operator, okay? Which means that I can convert B into an integer. And then I have a function that takes a make B, that takes two integers and constructs B with this syntax over here. Now, this syntax over here is called, is referred to uniform initialization, right? I return curly braces A and B. I know that I'm returning B, so I'm looking for a constructor for B that takes A and B. It might be a list initializer. It can be a struct initializer or a plain constructor. And here, you can see this, I just pass it. So I just deduce that what I need to do here is to construct B with these arguments. Then my function, we just initialize x equal 10, and this is a 10 dot, so it is a floating point number, double. And this will work because it will go here and say, I can convert the double into an integer, so I can call this constructor here, right? Here I can construct 34, 45. Well, this is obvious. It goes to this constructor. It takes 2 integers. And as it's an equal, so here is the same, is the same thing here, right? I don't see in this right-hand side, I don't see the type of this guy, but I know that I'm going to assign to a b, so I'm going to call the constructor of b, and then I have an integer I, then I can assign from y. So I can say y equal I, which will call this operator int, this conversion operator. Now, it might be that you don't want your user to write something like this. It feels a little bit strange to take a double and assign it to B. Maybe you want to control that. You don't want the user to do to actually get this implicit, because it might be that the semantics is not well defined for your type. So you start putting explicit keywords everywhere. You put the explicit keyword on the constructor, for instance, and on the conversion operator. And now I cannot do the uniform initialization anymore. I cannot just put AB and then get B out of it. I have to explicitly construct A here and put it back and return it. I cannot simply assign to 10, but I have to call a constructor that takes 10 dot that will be explicitly converted to int. This remains no, it doesn't remain the same. I need to construct. I cannot use the equal sign here. Again, I need to explicitly construct. And here I cannot convert directly to integer. I need to explicitly say static cast. So here I have more control. My user doesn't go too wild. If I need my user to do so, right? If it is completely fine because the model because A and B are clear what they do, then it's okay. But otherwise, I may want to control a little bit better what the user is doing. So, yep.
The last example, the last line, you could also have called directly the int operator.
You can call the int operator because it's a function call. Yeah, you have to call it operator int. You think so? Yeah. There is a function for that, so you can call the function equivalent of that guy. And then you don't need to do static cast because you're calling the function directly.
And on the right side, would you also be able to do int of I parentheses and y inside instead of using the equal?
Yes, I think so, yeah. Yes, because it can be converted to an int. We can try.
I think you should use curly braces.
For that? Yeah. We can try again.
I think conversion operator should be const. If I remember correctly. I'm sure it will compile with non-const conversion.
Let's try. Let's try. Okay, this compiles. And the idea is that you do this. Okay, well, no, if I put explicit, yeah. This shouldn't compile.
No, explicit.
Explicit. Okay, no, this... Okay, so this shouldn't compile. Yeah. And there I should put static assert. Let's say static assert not there. Yeah. Okay. Static cast. Goodness. Yeah, this compiles. Yeah, so if I do it explicitly, here it just goes, even with the explicit.
I think that so I'd like to note that this equal sign in the definition it is not assignment. It is not strictly speaking assignment.
Yeah.
And
Can you use the microphone? Then you
yes, and
need to.
as far as I remember,
I don't think it works.
Standard says that the copy constructor is not called is not called at all. So but if you add this assignment, this equal sign, it is so compiler interprets this initialization as a conversion.
Yeah.
And and that's it. There is no copy constructor involved.
Yeah, if you are initializing though the same type, I think it will call the copy constructor because this goes through overload resolution.
I think no.
Well, we can try. Have some example later on to see what then we can play with those. So what does this? What is the value of I? Indeterminate. This one is 0 initialization. It goes to 0. But if I have this, default construction of A, yeah?
I have some questions that I was trying the example that you just put now with the operator, the parentheses.
Yeah.
I mean, I can also call it using curly braces.
This one.
Yeah.
Yeah, also here actually. We just
That, like, for example, whenever I see a class example, you for example, typical example of a container.
Please use the microphone.
Yeah, sure. Just that I'm a little bit confused because
you have to press the button, the power button a little bit. It's difficult to reach.
no, it's empty, the battery here.
Ah,
It says it's empty.
okay.
No, just that I don't quite understand the idea of defining this operator, the parentheses, because usually, to mention an example, when you have the typical example of a container, this is typical. When you have to implement an operator, and then you implement the operator of the square brackets, then it's because you're defining like this function to call that operator, right? In this example, where you present the definition of the operator of this parentheses, I'm confused because it seems that I can call that.
It's not the parentheses. The operator is int.
Okay. My bad then.
The operator is an int. Yeah. So it is conversion operator.
All right.
Okay, so this is default constructed. This is also default constructed, right? So if I construct an object B with the empty curly braces, this is default constructed. What happens here? Do you know the syntax? Should be pretty self-explanatory in some sense. The default constructor is deleted, yeah. It's not generated, which means that this gives you a compile error.
So it is not the POD in this case?
No.
Because you are deleting the default constructor?
I get to that, which I find a little bit confusing, is the fact that if I do this, for this particular case, this will go into an aggregate construct. So it would initialize the values to 0. There are cases in which a deleted constructor is there, and cases in which it's not there. So here it's like if I delete the default constructor, this is still an aggregate. There are cases in which if I delete the move constructor, it doesn't perform the move. So it's kind of weird. We'll go to see this. Basically, you can construct B even though there's no default constructor because this is an aggregate. So in order to avoid this, you can put, for instance, another constructor or a private something, a private member function, something that that will make these the class not an aggregate. Otherwise, the user can do something like this. What happens here? What happens to E? Would it be constructed or not? No. Yeah. Who says no? Who says yes? Who says I gave up at this point? Well, it will be constructed. What happens is that this is calling the default constructor of C. Okay, it's not a default, it's a constructor with empty arguments. Now, the compiler goes into which functions are the one that I can call that can do this work for me. And there is a constructor here which takes an integer, but it has a default value of 10. So I can call this constructor with no argument, substituting 10 as the argument, and this will be actually compiled. This is called, again, overload resolution. So when you write that, the compiler will go and list all possible functions that you can call to initialize the object, or and then it will select the one that is the most appropriate. And in this case, what happens? Well, again, overload resolution. I find it a little bit confusing because I will say this shouldn't happen to me, but that's how it works. This one is an example of a struct initialization. So this is a struct, and I can initialize A to 2, B to 3, and then the YX of struct of the inner struct to 4 and 5. And you see this struct doesn't even have a name, right? But I can still put values in there. Well, it has a member, sorry, it's F, but the type doesn't have a name. So if I do this, what happens? This goes to the default constructor, which is automatically generated for you. So both syntax actually yield you an object. The first one has some prefigured values that you put in. The other one will be the automatic default constructor is 0 initialization. This one? error. It's a function declaration. This is why it's true. It's a valid C++ code. But when you see this, I never think this is a function declaration. I always see a construction of an object. And I have to go back and fix my code. This one? Yeah? No? This goes to struct initialization with all zeros, which is not exactly the same as the default constructor. It's basically the same as this guy here, only that all the values are 0. And it is basically what the default constructor does, but it is slightly different. They say, yeah. So this is basically struct initialization that can happen at compile time.
In the first case, if you omit the 4, 5 bracket,
it will be initialized to 0.
you can really only initialize.
Yeah, you can only put the first 2 numbers. Yeah. Which might be confusing. This might be confusing. So I have 4 members. What happens? I'm initializing only 2, right? But this is actually the expected behavior. Okay, let's see what I'm trying to do here. So I have a class C, which has 3 constructors. One takes an integer, another one an integer, and some value type, which is a float. By the way, in a C++ class, you can have type defs. This is a type def, and this is also is called the type member. So it is a totally valid way of putting this stuff. So now you can use value type here. And you can access this value type from outside. But we will see examples. And then you have a constructor that takes an int and a float, and then a constructor that takes initializer list. So in this case, I guess there's no doubt we go to the constructor with the integer. But here where we go? The initializer list constructor. This I find a little bit confusing myself in the sense that it really depends on the implementation of the class, what the syntaxes will do. And I don't particularly like it because I would like the syntax to be self-explanatory, but you need to know something about it, about the implementation in these cases. So it is very important when you design your classes that you specify exactly what the behavior of your object is. You don't want to end up in syntax that looks similar or that the user expects to C to behave like an int, but C, it doesn't behave like an int. Here it creates C10, just initialize a vector of size 10, and here it initializes inside the vector of size 1, right? So they have a different, very similar syntax, but very different results. And unless you have established with your user a precise contract, say this is how the class behave, you should be very careful and really design your stuff in a way that makes the user not be surprised by the code he writes. This one, again, goes to the constructor with the 2 elements, and this one goes to the list initializer again. We can go on. Let's see if this is worth doing it. Yeah, well, this is just already explained. In this case, there's no list initializer constructor, so all these syntax behave the same way. So the 2 constructors over here behave the same way, this behave in the same way. In C++ 11, we have introduction of the member initializer. It means that you can initialize data member of your class directly into your class, like here. This is something that happens only from C++ 11. And then what happens if I call x34? So what happens when I call xy here? And so the values of a and b will be 10 and 22, right? The full construction. What happens when I try this one? Well, it doesn't find a constructor, so this code doesn't compile, right? So what I can do is to create something like this. So I create a constructor that takes an integer and then assign to a. So this will be equivalent to a equal 34 and b equal 22. And what happens to this guy? Yeah, the default constructor is not there anymore. The default constructor is put in place if there's no other constructor. Now you put a constructor there, the compiler say, I'm not going to do any default constructor because I don't know the semantics of your object. Right? It's your object, I don't know how to do it. So instead, you can force the compiler to do a default constructor, which will initialize the field to 10 and 22. And in this case, this code will work.
Or put the default value for the parameter.
Yeah, that should also work. Yeah. I wouldn't do that, though. That was a dirty trick. You shouldn't do that kind of things. It's just to show what happens. Take the mic, Anton, please.
It doesn't work.
No, I think it works now.
You can do really evil things if you in the constructor from integer you can write a equals x plus a, for example.
Yeah. Oh, yeah, sure, because a has already a value. Yeah. But yeah, so it's a usual saying in C++ that there's nothing that prevents you from hurting yourself badly. So you can always shoot yourself in the foot in C++. And you should be very disciplined in not doing that. Even though sometimes it's tempted to be smart, it doesn't work well in the long run. And so this is where the KISS principle comes in. Keep it simple. So
when you write X default, the default constructor is called.
yeah,
Even though you actually
here, yeah.
are there, but in the upper X.
So here?
In
Yes,
the main
here-
function in the beginning, in the main function.
Yeah, in the main function in the beginning in this class here, this will call the default constructor, which is placed for you by the compiler. It's called the rule of zero. If you don't put anything,
Right,
you will get
but with the
defaulting
struct on
copy
the right,
constructor.
the last update,
The last update,
and then the first line in the main function.
this one,
Yeah, will b be initialized to 22 or not?
this will be, it will call this
Just that,
constructor, yes.
Ah, great, that makes sense. Thanks.
B will be initialized.
Yeah, B will be initialized to 22.
Ah, okay.
So these values are there basically before your object is born somehow, right?
Thank you.
So they always be there. So you don't have to initialize the values if they are already been initialized. I don't particularly like it because I want to see what I'm doing in one, when I'm constructing my object. It's just, I think, matter of taste. And also depends on what kind of object you are building. But so in C++ 11 and on, there are the concept of deleted and default constructors, but also deleted member functions. So the default constructor, so the default constructor will say y equal default. It will implement basically a 0 initialization, or it will do, or will take the initializer values for your data member. So here, if you delete the constructor, the compiler signals an error when you are trying to use that constructor. The problem is that sometimes the constructor is there anyway. Like this is called the move constructor, so the move assignment, and I am deleting it. So we will see what this guy is doing. But basically, we take another object of type X, this is struct X, and we perform a move or operation, which is a kind of clever way of copying without spending the time. And now, when you construct, so here, now this should actually work. Okay, so it's the default constructor and then yx. Okay. Now I'm taking x and I'm constructing y, and I should use the copy constructor, right? Taking the value of the same type and using the copy constructor, but I get a compiler error. And the error is very upsetting, I'll say. What you get if you compile this code is that the copy constructor, the signature of the copy constructor, has been deleted, and it has been deleted because X declared a move constructor or move assignment. So if you are doing a move operation, then the compiler will not do the copy automatically for you, which also makes sense. If you're doing something special for the move, it means your object has some pointer to somewhere, some resources that it owns. So it cannot safely implement the copy constructor. And so it will delete the copy constructor, and then the copy constructor will not exist. But I told the guy that I deleted this guy. I deleted the move assignment. But if I'm telling the compiler I want to delete this, it's still because there's something weird about my object. So the compiler doesn't do it for you, and you get this error message. And this can be extremely confusing. If you start writing the code and the code doesn't compile, yeah. So deletes also work for other member functions, other member functions, not just the constructors or the assignments operators. So you can delete any function. Here are the rules for the automatic constructors. Automatic functions, which are basically constructors, assignment, and destructors. But yeah, I won't go into the detail. We will get into the detail when we meet the problems. So now I can delete other things. I can default. So here, in this case, I can default the copy constructor because I know that the copy is just copying the value of A. So I can default the copy constructor. I can still delete the XX. So instead of writing by hand the copy constructor, which does nothing, I just can say write the default one. Yeah. So equal default is a way that you write also here. You don't want to write your function, say, because the function is obvious. In this case, when I do a copy, I will copy the data member. So I don't want to write the code that does it. I would say default construct. implement the default copy constructor, which is basically going recursively copying data members. The microphone?
Basically, in this slide, only for struct y, default constructor is meaningful, because without this default, default constructor is not generated.
Yes, exactly. There's no way you
because
can
we
get
have,
the 42.
Yes,
basically.
we have custom constructor already. For others example, this is no x equals default.
Yeah, but then also in these other examples are really kind of silly examples, just to show you what the property is, right?
The idea is that you just for example, in more complicated cases where, for example, y have a base class and or some other members and stuff like that, you don't want to default constructor being vanished if you if you define your custom constructor. And to prevent this, you use this default keyword for default constructor.
Any other questions? Just going a little bit ahead myself, this the copy initialization happens if I'm calling f of y, and y is taken as a value here. This will basically do a copy of y into x, and the function will take x. It will take a copy of y inside the function body and work on that. So x inside the function here will be copy constructed. If I'm constructing the value on the fly, here in this I created a value t. This is called a temporary object. So it's not something I can access. After f, I would not have access to that value there, right? It's passed to the function. It's given, and I cannot access the thing afterward because it doesn't have a name. There's no way I can reference this guy here. There's no way I can reference it. So this is actually moved constructed. And I can force this behavior. I can tell move. But yeah, this works also in this case when you have the move constructor with the default arguments and default copy constructors, but just too complex. So maybe bit fields. Just a quick bit on alignment. The C++ 11 introduces a line off and a line as. So you can take a variable and instantiate the variable with certain alignment characteristics. So you can also show here, you can show what is the alignment of char, of int, double, and float. And you will see what is the alignment value. The alignment value is the multiple of the power of 2 to which the address of one object of that type should be at, right? So a float will have 4 bytes, So we'll have to be, the address to a float has to be the last 2 bits at 0. A double, you'll have alignment of 8, so the last 3 bits of the of the address of a double will be 0. For a char is usually 1, so every address is valid. Then you can tell you can tell C++ how to align variables. For instance, I can tell my struct my struct B, I want to be aligned as double. So when I create an object of type B, it will be aligned as a double, so it will have an address which is a multiple of 8. And you can also do align as with multiple types. This is a variadic template thing we will see later. So we'll take the maximum alignment of the types that there are listed there. So if I do alignment of char and double, it will take the alignment of double because that is the one that has the largest alignment constraint. Which is useful sometimes. Usually, well, it really works just for the variables, right? So if you want to allocate the memory on the heap that is aligned, you need to use aligned locators, or you need to do some tricks yourself. The new statement will force alignment to, so if I do a new of double, it will be aligned as a double, for instance, but if I want to do other kind of alignments, for instance, 256 bytes, because I want to allocate data on the GPU in an efficient way, so I have to do some tricks. And the data alignment can actually influence the data layout of your classes. For instance, I have a class X, which has a char, an integer, and a char. And I have an struct Y, which is the same, char A, int B, and char C. But I want the int B to be aligned as a double. Then in memory, what happens is that A will have a char here, 4 bits of alignment, 4 bytes that are padding, just left empty. This is my member B, which is the integer, 4 bytes, for instance, and then C. And then I have other bytes here, padding for the next struct to be able to put arrays of these guys. For the Y, I have the A padding is much longer, so here was only 3 bytes. Here is 7 bytes because I told B to be aligned as a double. And there you can control, but you see that the size of X and the size of Y would not be the same. But here I can also just show you one case in which you want to do is align as 128, and I wanted a char array, like a byte arrays of that I called cache line, and this is 128. So for instance, if I know my cache line is 128 bytes, I can instantiate something like this, and this one will instantiate something which is aligned to a cache line. So I can also control, I know that that will fill exactly into a cache line. Yeah?
Can you go back? Can you go back? Yeah, no. So I don't understand why, if you say that align B as double, why you don't have A, the same A, pad, and then B, and then more pads at the end of B, not at the end of A.
No, because it's B which is aligned to, so the address of B must be multiple of 8. So when B starts at an address which is multiple of 8.
So the column on the left is the struct X?
On the left is X, on the Y is, on the right is Y.
Then I don't get it, because in X you don't say anything about the alignment, so you have char, int, and char, so that would be like 6 bytes, right?
Yeah, 12, but here you have a char, you have an integer has to be stored in a multiple of 4. Mm-hmm. This is why there will be, the compiler will put these padding bytes there too. Because B has to be multiple of 4 bytes because it's an integer. You cannot store the integer at the odd address. It must be multiple 4.
Also the char.
The char, well, here it happens. This one are because you have to, when you locate the vector of these guys, the next one has to be aligned the same way. So it's like there are padding bits at the end of your struct. Well, there was a little off topics just to show you this kind of keywords. I don't find these keywords very useful very often, but they are, if you want really to optimize code for your instruction sets or whatever, that it makes sense. For your cache hierarchy, it might be useful.